Awesome. Let me turn the audio off.
All right, I think a few more people are still coming in, so we'll give it 1 minute and then kick off. Oh, no. Let me just grab sorry, this is my water. Put this out of the way. Let me, we'll sort this out in a minute. Okay, we'll sort it out in a minute. All right, come in, please sit down. There's lots of spaces around this side, around the back. There you go. You want to get started in 1 minute. All right, let's get this show on the road. So, welcome everybody to Cloud Native London. We are a strong, open, diverse developer community based around cloud, data, and AI based in London. I'm your host. I'm Cheryl. You can find me online at Cheryl. I'm most recently of ARM. I've actually left that job. Google, Apple, a few other places. We have 3 talks for you tonight. So at 6:45, Martin's going to talk to us about revolutionizing your software delivery with AI-powered DevOps. 7:15, we have managing Kubernetes at scale, platforms, infrastructure, and cordons by another Martin. Then we're going to take a 15-minute break, 7:45, come back at 8 o'clock, and hear about how Google built a consistent global authorization system with Zanzibar, and you can too, from Sohan. At 8:30, we're going to wrap up for the evening. And for those who like to keep going, we're going to go to the Conductor Pub, which is just outside the building, 1 minute in front of you on the left, and keep chatting and having drinks and whatever else. Our sponsors for tonight, I'd like to say thank you very much to all of these and invite them up to the stage to take a minute. So TestCube, do I have someone from TestCube here? Okay, maybe not. Harness, do you want to do your intro now?
Hi everyone, I'm Ross from Harness. I won't be doing the talk tonight, that's Martin, he knows about technology. I don't, I'm just here for the stickers, which I've left some outside. I have loads more in my pocket if you want more, but yeah, if you've not come across us, we're a DevOps platform. I don't know if there's any customers of Harness in the room actually. You get special swag, if that helps. Okay, there's one over there, yeah. So yeah, we've actually got our own event in a few weeks' time as well. So Martin's going to talk a bit more about that. But yeah, hopefully you enjoyed the talk and hopefully you enjoyed the pizza. And please get some stickers, we've got loads.
Amazing, thank you very much. And then Mirantis. Yes, come and tell people at that minute.
It's a minute. What I'm supposed to tell them about? How many of you have heard of Mirantis? Some, none, a few. Especially if you're in OpenStack, you might have done it. Mirantis has been around for 20 years, based in San Jose. We have a large contingent of Europeans. Started in Europe. There's more of us than there is of them. And we are launching something called Cordon. We've already launched it, but it's our new way of doing things. That's it.
Very good. Thank you very much. And one more. So you can do your.
Hello, everyone. I'm Kunal. I'm the field CTO at Civo. Civo, we are a cloud provider. We do public cloud, private cloud, AI, GPUs, a bunch of other stuff. We do this conference every year, once in US, once in Europe, and once in India. And we're doing it in London again on September 30th. And you can sign up for free if you're attending this meetup. If you scan this QR code, the early bird tickets and the early tickets are all gone. So the one you see on the website is like 600 quid. But you can get this one for free if you're attending the Cloud Native London meetup. We have Kelsey Hightower coming. And in the past, we've had speakers like Steve Wozniak, the CTO of Reddit, and I think you spoke. Yeah. But yeah, if you scan this, you get it for free. So you can do that later. Yeah.
Thank you. Thank you, Kunal. Round of applause, please, for all of our sponsors for tonight. Thank you so much for supporting this event. And now a little bit about you guys. So if you've got your phone, please scan this QR code. We're going to do a little bit of live polling and ask a couple of questions about yourself and a couple of questions about how you use cloud data, cloud native. Have you got this? So first question, is this your first time at Cloud Native London? So you should see yes or no. And I can see people figuring it out already. Yep, you just press yes if it's your first time or no if it's not. Looking like I thought the no's were ahead, but actually yeses have pulled ahead. It's quite impressive, 60%. We also have people at home who are joining us on YouTube and on LinkedIn. So some of those might be live streaming. Let people, the no's gonna come back. I don't think so. I think we've settled at 59:41. Very nice. Next question, what's your job title? So pick whatever's closest. You have architect, application developer, backend developer, engineering manager, DevOps/platform engineer, security engineer, or anything else. So backend developers and really pulling ahead tonight. 30%. Good showing from DevOps and platform engineers. A couple of application developers too. Very good. All right. Let's go to our first question from one of our speakers. What's the biggest challenge your organization faces when trying to improve software delivery? Is it lack of skilled talent and resources? Is it legacy systems and technical debt? Balancing speed with quality and security? Manual and time-consuming processes? Or resistance to adopting new technologies? We'll give people a minute to consider. And looks like legacy systems and technical debts, as always. But yeah, balancing speed with quality and security. But Martin, so this question was yours. So is this what you expected? The answers that you expected from the audience?
It's pretty much in line with what we see in general. We've done whole sessions just around that legacy systems and technical debt and modernization. So yeah, for sure, 100%.
Good. It's good to hear that we're a representative sample, 36%. And curiously, and a similar kind of question here. So what's the biggest challenge your team faces in adopting platform engineering? So building the right developer self-service capabilities, balancing standardization with developer autonomy, managing complexity across multiple environments, or proving ROI to leadership. Subtly different, this one. And building the right developer self-service capabilities. Seems like it's pulling slightly ahead, but it's actually pretty even overall. Is that surprising? Martin, is that surprising, or is that kind of what you expected?
That's what I expected.
Yeah.
That's what I expected. So
Very interesting. Yeah, I don't know if I could have guessed like one would be bigger than more than the other. Yeah, I think the word right is it's doing heavy lifting there. The right ones is definitely hard. Nice. What authorization system do you use at work? We write our own, we have custom or custom authorization. We use centralized authorization, or we don't use or need authorization. This one's got a bit of a clearer bias, I think. So yes. Yeah, is this what you thought would be?
I'm a little surprised.
Not surprised. Why?
I didn't expect so much with the centralized authorization, but it's a pleasant surprise.
Okay, all right. I'm interested to hear more when you speak later. Also, like 6% of people don't use authorization at all. Want to know what you guys are doing? All right. Thank you for taking part in our live polling. Keep this up on your phones because we're going to do Q&A with the speakers through this as well. I need a selfie for social media, so everyone stay where you are, but I need a big smile and a big wave from you. Big smile, big wave. Not very, but before. If you would like to come and speak or sponsor us, then go to cloudnativelund.com. And we can also share your events if your companies are running conferences or events. And that is it from me. So I'd like to welcome now our first speaker to the stage, Martin. Round of applause, please, for Martin.
Need the mic. I need the mic. I will start when you let me share. Awesome. Thank you. Okay. Hi. So my name is Martin Reynolds. I'm field CTO at Harness. I have been there about 2 years, but before that, I built software for 30 years. I have the gray hair to prove it and quite a lot of wrinkles. A lot of that time was genuinely building software, although towards the last kind of 8-10 years of before I joined Harness, I put my first product into cloud, followed it by another 39 that I put into cloud from existing systems, and went from running engineering teams to DevOps teams, which became platform engineering teams, and that's and then I joined Harness. So that's kind of been my own personal journey. So today we're going to talk about how you can revolutionize your software delivery with AI-powered DevOps. Before I jump in, I know we had a little pitch about what Harness is, but rather than a big description of all of our products and all, whatever we do, I think our mission statement sums up what we're about most of all. And actually, it's one of the reasons I joined the company, is we want to enable the 37 million software developers to deliver code quickly, reliably, efficiently, and securely. And I'm going to get into some of the details behind that and then show you some of the things that are possible when you bring AI into the solution. And then maybe, when it gets to questions, we can talk about how you get the AI into the solution. Just dropping across here. So this is kind of where software engineers spend their time. We gather this data across actually multiple sources. So we've run our own surveys across hundreds of software engineers and software teams. But we've also done this kind of, other people have seen the same thing where 30 to 40% of developers' time is spent, planning and coding. And then 60 to 70% of the time is spent to the right of that. So whether that's, testing, building, securing it, deploying it, responding to those security scans, whatever it is, or even just optimizing it once it's deployed. So, how does that really break down in that right-hand side? So where they're spending the 60 to 70% of their time, how are they spending that? Well, actually, 42% of that time is in manual testing. Still, now in 2025, 42% is around manual testing and that failure risk to do with that. Then security is often siloed, so it happens somewhere else and comes back. So you get that terrible feedback loop. Generally, when I was developing, I want to know everything in the PR and be done so that when I merge the PR, I know I'm done. I don't want to have to come back to it a week later, 2 weeks later, or however long it takes for the security team to do whatever it is that the security team do. I did notice, by the way, that there was no security people when they did the job titles, which I thought was interesting. Then there is, just the deployment and the scripting and, having come from a background of using Jenkins and various other things in the past, there's a lot of scripting. I am happy if I never see another line of Groovy script in my life, because I've seen far too many of those over my time. And ultimately the optimization piece is quite inefficient. So here we're talking about, managing those cloud costs, which, especially if you're in public cloud, can rack up pretty quickly, especially when you're not sizing correctly or you don't have, the appropriate scaling and dynamic stuff set up. So, sure. These came from multiple places. So I can share with you afterwards explicitly where they came from. So we've run a couple of surveys, which are normally at least 400 software engineers from 400 companies. And we've done separate ones with management, but we've also taken just industry benchmarks of where those numbers come from. So as in people like Google and some of the other. Yeah. There's actually the reports are all on the website that have that detail in. Yeah, if you go to our site, you can go to the software delivery report and there's a DevOps report. We do them annually. There's actually 4 because there's a feature flag focused one and a chaos one. AI one as well, yeah. Yeah, I'm coming to that. So, yeah. So, with the explosion of AI code, and we've seen a massive explosion of AI code, one of the most interesting stats I've seen probably of the last 12 months was when, Google brought out the Dora report and they said, yes, there's loads more code generated, but actually almost no new features it hasn't actually increased the throughput. It's generated lots more code, but it's not actually triggered any deployment. And, our view on that really is all those things to the right of the generated code are actually things that you need to fix too. In the same way that if you're generating more code, that means you need to generate more tests. It's more security issues are likely to be found in the generated code or even in the code that's there. Deployments are probably bigger, which means they're riskier, and then the optimization of that, becomes even more complicated because if you haven't written that code and it hasn't had a good review and got all the right steps in place, it's going to cause a problem. So obviously we say we fix that. So, and kind of how do we do that? So, the core of our platform, honestly, is the pipeline orchestration. Harness started around 9.5 years ago. I know it quite well. I was actually customer number 4. I was customer number 1 in Europe. So I was a very early adopter. Back then it was just CD. There's a lot more now. We'll come to that. But, that intelligent pipeline orchestration is probably the core of the platform, and it's in almost everything we do. So, whether that is, your CI, your CD, your security testing, your internal developer portal workflows, your cloud cost governance, all of those things, we have pipelines in and around because that orchestration piece is so key. So we have automated governance so that you don't have manual stage gates, and these things, by the way, I'm saying that we do them, but these are the things that help solve those problems. Whether you're using Harness or not, these things apply regardless. So, that integrated security into the SDLC. And we do like to talk about shift left a lot, but really it's about shifting the information left and not shifting the work left, because I don't feel like engineers should do everybody's job. They should do their job and get the right information at the right time from the right people. Unified FinOps and DevOps, so you can see how much the changes you're making cost. And then, flexible and reusable templates, because you don't want to build a new pipeline every time you have a new service to deploy. So I am actually going to skip over these. They were in the built slide, and these are where some of our customers that we already have been using the product to kind of improve these areas. I won't go into those in detail though, because what I want to do is just quickly show you this and then actually show you what it really looks like and what it means and how some of those things really impact. So at Harness, we say we're AI native. We actually had our first ML AI stuff in that very first version of the product. We had something called continuous verification, which post-deployment uses ML to understand what good looks like for a deployment. And then when it sees variations, it says, I think you might want to roll back here. And it can either do that automatically or prompt someone to do that, rather than somebody trawl through all the logs, all the Datadog stuff and the application logs and everything else that's in there. It's been there since then, and we've been building it in to the platform ever since then. What we've done over the past kind of 12, 18 months is we've started to build out this software delivery knowledge graph, because we know how people deploy their products, how they test them, how they check for resilience, how they manage costs. We've taken that to build a big software delivery graph from everything from code to post-production. So we understand how people are building and deploying their software. Then we're using that to actually build agentic workflows. And then how do we apply that? I'm going to do this fairly quickly. We have a lot of modules, right? Harness is a modular platform. Some of our customers have 1 module. Some of our customers have 10. I'm not sure any of them have however many we're at now, 17, 18, 19. There's some new announcements. So, but we actually focus it around, DevOps for velocity. And, there's all the things that we do inside that DevOps space. We have testing for reliability, whether that's like feature flags, chaos engineering, site reliability, or even test automation, which I am going to show you in a little bit, because honestly, it's one of my favorite things we've launched, only because I used to have huge test teams that were often bigger than the development teams to do all the testing of the web applications. So I do understand that pain explicitly. AppSec for security. So, again, that end-to-end security with single pane of glass visibility. And then, Cloud Cost and software engineering insights, which is more about, where are the bottlenecks in that pipeline? So where are the bottlenecks between start and finish? So before I get into these, and because these are a bit of a preview, the next few, I'm actually going to drop into the product really quickly. I'll try not to. And what I'm going to do is I'm going to kind of just, is that? It's not. Okay. So what I'm going to do is I'm going to kind of talk about, this is Harness. I'm not going to go into lots of detail about it. As I said, it is a modular platform, and you can kind of see all the modules there. Obviously, if you're, I now actually want to go back a page because I wanted to be on that page. So what we have here is, this is a whole pipeline. We talked about the intelligent pipeline orchestration. This is a pipeline that kind of has a little bit of everything in it. So it has kind of, build, test, push that to your artifact storage, set up a dev cluster using infrastructure as code, deploy it to dev, deploy it to QA, get a final approval, deploy to prod. I've deliberately left the fact that it's failed its deployment because I want to show you that too. I don't want to take lots of times, but I want to kind of call out some of where we're starting to use AI to really accelerate the way we're delivering. So one of the first things I'd call out is right here, you have this thing that says, hey, it's saved 16 minutes and 20 seconds in this build process. And it's done that using AI. Well, how has it done that? So if I scroll across here at the bottom, you'll see I have something here called test intelligence and build intelligence. So what do they do? So, build intelligence does things like smart caching around common builds, around dependencies that haven't changed. It even will recognize if you have a build step and none of the inputs have changed on that build step, it won't execute. It will use the cached output for that, which obviously accelerates it. And the one that's actually kind of more exciting and often saves the most time is test intelligence. So I'm just going to switch over here to this tests tab right here. So what you can see here on this screen is over here, it's telling you that there's 12,700 tests in this particular project, unit tests, but it actually only ran 1,503. So why did it do that? So essentially what it did is it analyzed the code that had changed and said, okay, these unit tests call something either directly or indirectly that is impacted by that code change. And all these other tests don't. And the easiest way I can describe that is, if you change the wing mirror on your car, you might check the electric thing, to make sure it's still moving it. And you might check that it's not broken anymore. Are you really going to run a full engine check and everything else, check the tires when you've just changed the mirror? That's kind of the principle that we're applying here. And obviously, when you've got 12,700 tests, that actually makes quite a big difference in the time it takes to execute. Across the piece. So as well as that, it also does smart parallelization. So it will work out which tests can be run in parallel automatically. So these are all places where we're starting to use AI to accelerate things to the right. So one of the other things I wanted to talk about in here really quickly is you can see, like most orgs, in fact, everybody here has to run security scans, right? Before they build and deploy. That's got to be a thing. So, and most organizations run more than one. So one of the things that we specifically do here is we, first of all, we make sure that those tests are governed. And so, it might be, hey, if my PR has new critical vulnerabilities in it, fail the PR. But what you want to be able to do as the engineer is just see the thing you need to fix. So to do that, if I go to the vulnerabilities over here, it's giving me a summary. Okay, and it's actually telling me that I added one, right? I've added one critical. So I can actually filter down to that critical and see what that critical is. I can see what it is. And actually, in this example, there's no remediation from Black Duck. This particular bug came from Black Duck, this security vulnerability. However, the Harness AI tool has actually had a look at that, had a look at the code and said, hey, this is actually how you can remediate against that vulnerability. So even though the security scanner itself isn't given a remediation, Harness AI has actually done that so that you can actually go ahead, make that change, rebuild it and get it to pass that security test. So just dropping back to the pipeline really quickly. There's only a couple more things I want to call out because I am very conscious of the time. And I do want to talk about some of the other things. So I think one of the other things I did want to call out is around that UI testing. So what we've done with AI testing. So if you've done any UI type testing, you know there's a lot of especially if you use tools like Selenium, there's working out which div and tag and finding those fields and populating them. And they're very brittle. And if you change the layout, it can break it. If you add a new field on the page, it can break it. It's very, very painful. So what we've actually done is we've built an AI tool that essentially takes your essentially your natural language and says, and I'm going to use this test here, which is purchase 5-star. So essentially what this does is I have a thing that says, essentially, I want to buy. I actually don't want to show you the edit. I want to show you running because it generates all that stuff for you. So I'm going to run this test, but essentially I've said, I want to buy some 5-star trainers from the store and fill in all the purchase details and then check out. That's the test I want to run, right? So that's what I provided. So what we're going to do is we're going to go in here and we're going to go into the detail. So it's going in with those things and the steps I've added, and what it's actually going to do is it's going to analyze, understand, and then work out what all the steps are to do that. So behind here, it's found some 5-star trainers. It added them to the basket. Now it's actually filling in. So this is the live screenshot as it's running the test right here on the left. It's now going to start generating automatic test data and filling those in. Now, the joy of this, while this is running, the joy of this is that if you change the layout and change all the colors and the fonts and the field tags, doesn't matter, because AI is actually understanding the context of the page, and it would still be a pair of trainers that it's trying to buy rather than, excuse me, rather than, working out anything else underneath the covers. And so that's kind of, when I saw this for the first time, which was about a year and a bit ago when we started working on this, 1.5 years ago, I was blown away just because, it is such a game changer in terms of testing, because if you have really good, well-defined stories that have test criteria attached to them, those test criteria on your story are literally the text that you can feed into your test AI test tool, right? I need to be able to do this as persona this, follow these steps, and this is the outcome I should define, right? Beyond that, this is actually quite smart. So, if you told it to put a discount in, it actually adds in tests to check that the basket adds up correctly and that it's applied the discount correctly, that everything's happened in exactly the right way. You can also, if you've got an existing site, tell it to just go in and explore the site, understand it, and build a set of recommended tests. So if you don't have those AI tests now, it's actually a really great way to get quick started on it. So what I want to do now is I'm going to let that finish running. What I want to do now is, you heard us mention that we have our own Harness Unscripted conference that is coming up on the 25th. Just make sure I'm getting that date right. Here in London, it is free to attend. The conference, we're running this in multiple locations. London is actually the last venue that we're running it at. It is also probably the biggest, certainly based on last year, is the one where we had the highest attendance. The whole conference is very much focused around AOps and the software delivery AOps, AI and the software delivery lifecycle. What I'm going to give you here is a little preview of some of the things that we're going to be talking about, and then a kind of final summary about some of the people who are speaking. So, under AI for DevOps, we're going to be talking about the AI pipeline builder. So, that kind of idea that please build me a pipeline to deploy to build and deploy my Java Spring Boot application to EKS on AWS using blue-green deployments, it will build that pipeline for you. So instead of you going in and building all those steps, it will do it for you. So, you know, it also does recommendations and various other things. AI verification and rollback. So we've taken that continuous verification that I told you about, and we've expanded that with AI, so it can actually help you find where in the code that failure is coming from and get more into the detail behind that. We have AI auto fix, which is really a, you know, hey, here's the security vulnerability. Let's just automatically put this into the PR and get it, or create a PR and get that approved by review. Or let's fix this coding bug that we found during the test. Whatever it is. And then autonomous code maintenance is actually, again, similar thing about actually just making sure that all that code stays up to date, that all your versions are applied with the right rules that you use for in terms of increasing your versions of your dependencies, etc. Doing that all in a governed way using Open Policy Agent. We also have some developer collaboration stuff that we put in. So IDP Knowledge Assistant. So you can literally buy you know, inside your IDE, you can ask questions of your IDP. So your service status, maybe run a workflow inside your IDP that says, you know, can you provision me some new K8 infrastructure that I can use for testing? And if there's a workflow there, it will do it for you. You know, or what's my service status? When was it last deployed? All of those kind of things are going to be in there. Also, and this is something that actually when I was a customer, I was asking for this, although not from AI based, I was just asking for release management, because in the perfect world, everybody deploys nice single autonomous services and you can have a really nice pipeline and there's no dependencies between service A and service B and service C and your database, except in the real world, especially in those legacy and technical debt type systems, you absolutely need to orchestrate your deployments to say, hey, I need to deploy the database first, then I need to deploy these services. And if these are all okay, then I can deploy this. And then when all of those things are done, we can actually do some final testing and deploy. You know, we know those systems still exist. Rather than chaining or making super complicated pipelines, actually having, you know, release management to do that and using AI to understand all of that context and give you meaningful updates is something that we've been building on and are now releasing. And then we have AI for development. So one of the things that we've been doing, as we've been building out all these models and everything else, we realized that we needed to have a specific AI MLOps functionality. So that's what we built. So we can actually have pipelines for AI and MLOps. We can actually have artifact repository for those models that we build and apply all the same governance and security and validation and testing that you would want in your software delivery. The same applies to the models and the AI that you're building in your organizations and that we're building in ours too. AI for testing, you've already seen AI test automation. We also have AI for SRE, and we have AI for chaos recommendations, which is another one of my favorites, by the way, because if you're new to chaos testing and you want to get started, using AI to kind of generate that kind of first 80% of the tests that you might want, maybe within your Kubernetes cluster, to say, hey, I've looked at the services, the way they talk to each other. Now I want to, you know, here's some sensible tests that will give you at least a good idea of what your resiliency is, and maybe give you an idea of where you need to address the resiliency without having to write all those tests and understand it. So, you know, get a quick start beyond what it does in terms of recommendations as it continues to operate and monitor in there. So last slide, which is all of this is happening on the 25th of September, 9 a.m. to 6 p.m. As you can see, we've got a whole raft of topics all around software delivery. All those people at the bottom are people who are speaking. So Global Payments, Google Cloud are there, Multiverse, Revolut, Lloyds Bank, EasyJet. These are all people who are speaking on the day, talking about what they're doing with AI and how they're delivering software using those tools. So, you know, we absolutely would love to have you. You can scan that QR code, come along for free. It's a whole day event, and there's even a happy hour at the end with free beer. So after that, I'm done.
Fantastic. Thank you so much, Martin. Looks like we've got a couple of questions already from coming in from the polling. So let's start with the bottom one. Does Harness augment / complement GitHub Actions / GitHub Advanced Security, or is it a replacement / alternatives / substitutes?
Actually, both. So one of the things we pride ourselves on at Harness is that we will work with any other tool that is out there. So, if say you're using GitHub Actions to do your build, but we might do your deployment, or we might do your security test orchestration, which includes GitHub Advanced Security plus other stuff. So your SAST and DAST scanning that you might do beyond your repository scanning. So we have customers, for example, who have GitHub Actions, but then they use us for CD and us for security testing and us for chaos, but they might use somebody else for their other testing and they use somebody else for their cloud cost management. We have more than 100 native integrations right out the box. And if there's no native integration, there's API integrations that are available also.
All right, next one. A 2025 MTRT study found that experienced developers using early AI coding tools actually became 19% slower. Pipelines are more customized based on unique requirements compared to application code. Wouldn't it take longer to review and debug the generated pipeline than write from scratch?
Generally not. So there's a couple of things to talk about there, and context is everything in this. So if you're using the AI agent to generate a new pipeline, Harness is very much built around templates, and you can build templates from individual steps to stages to the overall pipeline. So you can have templates for all of those things. What it specifically does, though, is understand your context and your governance rules, so it can generate it. So generally not, if that makes sense. So it generally doesn't take more time because it's actually using what you've done already. And also what we've learned from doing, I think it was 182 million deployments over the last 12 months. So we feel like we have a good idea of what good looks like in terms of a pipeline. And certainly, when you're talking about pipelines, they actually tend to be more generic than the code processes because you tend to have very common stages in terms of you must run these security scans, you're building using these tools, you're deploying to these known infrastructures. So, there is a much more common approach to those things.
Okay, next one. How are you doing the context engineering guardrails?
Okay. The context engineering is quite a big topic, and essentially for the context engineering side, and we're using the information, and we have a way of separating that out. So per customer, so we have the global learning, and then we have the per customer learning, which gives that context aware, which you would feed into the AI agents. In terms of guardrails, we use OPA extensively throughout the platform. It's actually embedded in the platform layer. Every single module that we build has OPA built into it. All the rules that you can apply that belong to your organization, you can create those as OPA rules and apply them across the whole platform. It's one of the most common use cases, especially in regulated environments, is to have those, those policies in place. And that's how we do things like take away manual approvals, because we can show in an audited way that we've applied those policies that need to be in place. So OPA is the foundation of those guardrails. In terms of the context engineering, that is very much around the global versus the customer level, and we have a separation between those to make sure that the customer gets their context and no one else's, and no one else gets theirs. But I have a separate slide that goes into that in detail, but it's a long explanation. So,
okay, we'll take one more. Does Harness capture video evidence while doing AI testing?
Yes.
Nice. Okay, good, excellent. All right, thank you so much, Martin. A round of applause, please. And I know there was another question up here or two that didn't have time to answer, but please try and find Martin in the break or afterwards to keep going. Okay, so come on up. We have our second Martin of the evening, and you feel free to join, and over to you.
Just join it. Share. All right. Midway, that was a really good talk. So I don't know if I'll be able to do as well as that. So we'll see. How many of you working with Kubernetes today, right now? Several, couple. How many of you using Swarm today? No? All right. I know. How many of you are using Watchman today? Remember Watchman? That's way back the mist of time. Okay. All right. So I'm here to talk about Cordant, which is a Kubernetes engine that we have developed. We released it about 6 months ago. It was built, maybe the start of it, June of last year. So it's very, very new. And this is a tagline. It's supposed to get you interested in it. And it basically says, Cordant, the platform that killed its past to build your future. And I will explain. All right, so evolution of where we've all been. I think a lot of you are quite familiar with this. Depends on when you came into the industry. Some have more gray hair than others, right? But kubectl was the thing in 2014. Basically CNCF, Kubernetes, and we all got into our Terraform. I think a lot of you might still be using Terraform, maybe, possibly. Then 2019, Cluster API came in. I don't know if any of you guys know Richard Case. He's a good guy, local London. He was one of the ones, he's the one who developed it for AWS. And then suddenly we decided we were platform engineering teams, and that's what we were going to do. And then ChatGPT happened, right? So that's what happened. Who was the one who asked for the stats from the previous? I'll send you these stats too, because I got them. All right, just so you know. All right, this is a snapshot based out of CNCF survey. So 89% of all those who were surveyed are running multiple clusters, because they did the survey at the CNCF Foundation at the summit, right? So obviously this is going to happen. It's a little skewed, all right? And those surveyed, they run 10 plus clusters. Obviously, again, a little skewed because you're asking people at that place. Time wasted in operations, 60%. Then these other things start coming up, like GPUs, right? GPUs, we wouldn't have really cared about asking those questions 2 years ago. Suddenly last year, we wanted to talk about it. And 73% said that was their biggest constraint. I can't buy the GPUs. And then 0% are happy with their current platform. All right, quite telling that quite a bit has changed. So we had at Mirantis something called Mirantis Kubernetes Engine, MKE. Originally started life as Swarm. And then it moved over to Kubernetes. We also had a different Kubernetes platform, but this is the one that was very, very popular. And commercially, we did really well. 5,000 production clusters, generating over 100 million off of MKE. Lots of Fortune 500 customers, especially if you swipe your credit card, any of them, you're using MKE underneath. But we sunset it. We sunset it. And the reason why is because the world has changed, right? If you look at where we were when you started designing, a lot, MKE was built at a time, and the other platforms too, but I'm not going to point out different companies. But those platforms were all built foundationally 2010, 2015. That's when we were really doing things, right? Really building stuff, had an idea of what was going on with Kubernetes. I was at Weaveworks at the time. We thought we knew everything. We really wrote a great product, and it had the certain things, right? Single data center or a single CSP for sure, right? Well, we're an AWS shop, we're an Azure shop. Perimeter security, very, very, very important in those days. Still is now, sort of. Maybe SOX, maybe PCI, maybe one of the other ones. Docker versus Kubernetes debate still raged back in 2015. I mean, we tried and sell Kubernetes, and people were telling us we're fine with containers, go away. And VMs were still king, right? Today, what do we have? You're running a lot more clusters because you've all been burned by running one big fat cluster and having multiple namespaces and realizing why that's a really bad idea, right? You now have zero trust that you have to live and die by. Sovereign, super important. DORA, not Kubernetes DORA, but the actual Digital Resilience Act, GDRP, AI, ML everywhere, can't turn around. Every talk's going to have it. And then when you leave here, you're going to read more about AI, you're write about AI, and GPUs are gold. They are gold. So the world has changed. Platforms, we looked at MKE, and it was built for that 2011 to 2017 mindset, mentality, how we're going to do things. Suddenly, all of our requirements changed, right? So at Mirantis, we stopped everything, literally, and reset the software platform as we did. Okay. So we called it Cordant. Cordant is a play on the name Arthur Dent. Arthur Dent, some of you might know, if you know about the number 42, et cetera, et cetera. You'll see it themed through in here. Hitchhiker's Guide to the Galaxy is my CTO's favorite story. So if you find things in here, let me know, I'll get you a t-shirt. All right, so here's what we came up with. It needs to be cloud native. It needs to be Kubernetes based. It has to be 100% declarative, 100% composable. It has to be able to talk to any cloud, anywhere. It's an edge, it's your on-prem, it's your VMware pain that you're enduring if you've got that. It's Azure, it's Microsoft, it's Alibaba, it's Hertzner, doesn't matter. You have to talk to it, period. The golden pass is security and scale. Obviously, we had to bake in. So, within what we built, there's a lot of Kyverno. There's a lot of OPA in there as well, too, right? Because we found that there's gaps in one over the other. And so we had to do a lot of work there. And we designed this to be optimized for modern workloads. If you need to still run traditional workloads, your old enterprise workloads that were, 2010 requirements, we still sell MKE, okay? We do. And you can still purchase everybody else's platform as well. This is designed for AI and ML. And the other thing is 100% open source, right? So what you purchase for your organization and what you can download off of GitHub, exactly the same source code, period, right? What we do for the enterprise side is we do security scanning. We build OCI images. We put in the SIG store. We do all that stuff. You get to sue us for, whatever you negotiate, 10 million, 20 million, whatever that is. So there's a reason why there's a commercial offering as well. But if you so choose, as a home labber, maybe, to run this, you can, if you want. So these were the design requirements. Tell me if we missed anything. Open source foundation, no vendor lock-in. This is a requirement these days, as you guys know. Kubernetes, cloud native architecture. K8s. We have K0s. It's now part of the CNCF. We donated it there, but we'll support any Kubernetes distro. Multi-cloud experience. So from the same control panel where you are, you'll be able to manage all of your different clusters in your fleet. Build all the enterprise features and ready for the AI ML workloads. And when I say that, what I mean by that is that, there's a vector database that's just come out that your development team absolutely needs, and there's no support or company behind it. You have to accommodate for that, right? So we built this to be able to do those types of things. All right. For the poor people who have to actually manage this, right? Which I think is a lot of us in here, maybe. This is what sort of the requirements were. We have to be able to do modern workloads. We have to be able to do emerging technologies because the development teams, the data scientists, whoever, they're asking for all these things, and there's no vendor out there who's able to provide it, but you still have to do it, right, for your employer. You need to enable the developers for self-service with guardrails, strict guardrails, enforce compliance, and then business needs. So all of the things, it's what your customers all want, right? If you're in the platform engineering team. And then for the platform engineering team, make this simpler, right? Please, for God. A CAPI YAML is what, 800 lines of YAML on average? Why is it like that? It makes no sense at all. So part of the thing we did was, let's do design by template. Let's create templates. So instead of 800 lines of YAML, now you're looking at 20, right? And with the introduction of KYAML that's just come out, we'll be able to get it probably down to 5 or 10, right? So that's the goal. And be able to say, yes, department AI will be able to support you with your new deployments. So that's what we said we were going to have to do. This is just sort of a rehashing of the same thing. But this, you can tell, target audience here is largely on platforms, composable templates, then modern workloads. This is a reinforcer slide here. That's what we built Coordinate for. All right. So what is it made up of? There's generally 3 pillars in this thing. It is a design by template platform. Package, whatever you want to call it. And we've broken this down logically into sort of 3 different groupings, as it were, right? So there's 3 controllers. There's a 4th one coming. I can talk about that a little bit. The first one is cluster management. So this is the component of Coordinate that is able to abstract and to be able to create those YAML templates for you so that you put information in there for AWS easily. You put the information in for Azure, you put the information in for any of your clouds, your edge cloud, your on-prem here, your on-prem in North America, whatever those different things are. Right now, I think we have something like 20 cloud providers that we're supporting. We also have bring your own capabilities for you might have your own unique requirements in how you built an internal cloud or some other thing. So that's all there, right? And it essentially says, this is what a cluster is. This is a cluster. The cluster is, it's an AWS one, it's a small, and it has between 5 and 10 clusters in there. I'll talk about the 5 and 10 in a minute. Right? So that's what it does. Second real key core component is your state, right? What is the state of my cluster? How do I control the state of my cluster? As a platform engineering team, you want to ensure that it's got Nginx egress. You want to make sure that it's got Kyverno. You want to make sure that it's got Kyverno default policies that you're enforcing. You want to make sure it had these types of items, right? Things that you want to be able to roll out as a platform engineer. So that's what state management is. In addition to that, these service templates, because we're doing template by design, it means your development team can then also build those templates as well for their own applications too, if they so choose, right? It's nothing mandatory in Courtney. It's if they so choose, you could do that. It'll make your life a lot easier. So I would promote it if you could, if you take a look at this. And then the last piece, observability and FinOps. Spent a lot of time investing in how can we tell what the state is of these clusters? Is there drift? How is drift happening? Where are the deployments? What are they doing? And then we've pulled in a lot of the open cost, cube cost items in there and tried to make it more integrated so you're not yelling at everybody when you're trying to deploy open cost in a way. So we've done this so that you'll be able to import and you can start seeing this is what this costs. Here are the different pieces that we have in the costs of these things that are running. And now we've developed the forecasting too. So as you start running these, and we use some statistics, it's not AI, it's statistics what we're using for this, okay? You can start determining what the cost will look like for different workloads from different providers. So when you're planning out a new deployment, you can say it's going to be smarter for us to run it over here or over there. Or in the evenings, we're going to run it on Azure over here. And in the mornings, we're going to run it on Ali Cloud over here, right? And you start to be able to do a lot of this. So those are the three. Bear with me. I know it's been a long day. It's hump day today, right? It's Wednesday. So bear with me. I will try and not put you to sleep. So this is what your cluster template looks like. This YAML. It's super simple. You put in your basic credentials, what it is, size, whatever. You can deploy it as is, like this way. Okay. All of this is strictly enforced with RBAC. So you can say, in my organization, platform leads are allowed to design this template. My platform engineers who are just starting off, they're not allowed to create these. But what they can do is they can define certain things that I'll allow them to do. And through RBAC, just standard Kubernetes RBAC, you can do that. And then you can actually then scale that out to DevOps teams that are working with dev teams or application developers too. So you can start giving them, so they're saying, well, I want to deploy a small test. It's going to be 3. I'm going to use the number 3, deploy it. Suddenly there's a little bit of, they can suddenly deploy a cluster, right? Usually it takes a little bit longer. Service templates, very, very similar. There's a service chain. You define all your services in here. This one's an example of Nginx controller in here. Tell it the version number, replica counts. A replica count is something, again, that, as a platform lead, you could say, I'm going to allow the platform engineers to change that replica count, or you can have the application teams do it too. All depending on what you're allowed to do by your company policy, what you have with your own internal policies, whatever you want. The only other thing I really want to cover is drift detection. It's rock solid, right? So if somebody goes and installs a different one, it'll get caught, flagged, it'll get rolled back, and you'll keep on going. Okay. So quite a bit of that. I'm just trying to get through a lot of content here as well. Cluster templates. What is a cluster? It's an Amazon one. This is your services. And then, FinOps is the same thing again. always using templates, simply by design. And have your students start having a lot of fun with this. I'm going to go on a tangent here for a second. You know, templates are really good to play around with AI. They're saying you can do a lot of things there that are a little harder to do if you don't have the templates in the system, the controllers that are built around there, right? So we have a KCM controller, we have this, a service management controller, FinOps controller. All right. We also wanted to make sure that we didn't recreate mistakes from the past. One of the biggest mistakes from the past is how many people here like Argo CD? Raise the hands. How many people here like Flex CD? Raise the hands. One or two. Okay. You better, because I'll tell Alexis if you didn't put your hand up. So, you know, you're able to start doing things because you're creating service templates and then handing them over to your development teams, whoever, that you can have one development team that's going to say, we only do Flex, right? And another one that says, we only do Argo. You get a service template from Mirantis, you can do that one too. You can start really being able to customize your deployments easily in a managed way for all your different teams, right? And they will see that, and you can give them flexibility in what they get from those components. All right, the journey so far, 42, Hitchhiker's Guide to the Galaxy. I think most of you don't know what that is, but anyway, it's a thing. All right, so how have we done so far? So we killed the old product line. We've created this. We've gone out and taken quite a risk by doing it. We still have customers that want MKE. I have a last slide about that. Anyway, so how's it going? Or what is it? So this is what this is where we're actually starting to really hit a lot of big things. The type of customers we're attracting are the ones who are stuck with this new workloads. I'm desperately trying not to say the acronym that starts with an A and ends with an I, because it's more than just that, right? But it's this new way of doing things that is difficult to do on previous generation platforms like MKE or others, right? And so we've had a shocking amount of people adopting this faster than we thought. But I think one of the things was we were smart enough to identify we had a problem and to come out and get something available early. So I think that's what we've done. Unfortunately, the only one I can really talk about publicly right now is Nebel. They're pretty big in Europe, sovereign AI, doing all those things. That's full production. They've got lots and lots of customers. So that's the one. But if you look at what it is, it's this important for AI inference, training workloads. Another big one, especially in France, for us with the French government, is this whole thing called Sovereign that some of you might know. One of the great things about doing with Cordant, which you can do, and if you're interested and your company wants to do it or something, or I can just chit chat about it too, is you can have these clusters with the mothership, and then you have motherships underneath the mothership, and then you can actually use a way to isolate so that you can have sovereignty inside of a huge fleet where you can have 2 or 3 different sovereign states inside of there. Sovereign state clusters, groupings of clusters, whatever those are. So there's a lot of things that this platform allows you to do because it's using templates, because of the way you're using a lot of different things. And then, the Neo clouds, A lot of them would like a lot of help too. So we're doing really well for literally 3 months of now we have something for you to do. Several banks in the US. Yeah, so it's going well. I'm going as fast as I can. So key benefits that they've come out with the data platform. I apologize, I had to put this in here, but GPU infrastructure efficiency. Okay. Hello. Okay. GPU efficiency. So we've been able to do a lot of that. I think we're one of the only Kubernetes platforms right now that can slice GPUs both ways. So both vertical and horizontal, if you guys know what I'm talking about. So we're able to do that. We're able to do sharding as well, reduce GPU idle. We're able to do things, again, just because of design. It's not because we're smarter, it's because we figured out a design that works. Compliance is another one because of all the way that we do the templating, that the controller is recording everything that is done and who did it and when they did it. We're able to meet a lot of the compliance requirements that are needed to the point where we can actually gate, ungate. You can do all of that. AI observability, we're doing this real-time GPU health and utilization. That's getting released next month, so I wouldn't get too worried about it right now. And we're able to really do a lot of life cycle acceleration. So working with NVIDIA right now with several other customers too, and that piece, the AI life cycle acceleration, is the burning thing that they want to solve, right? Because a lot of customers have those GPUs sitting there idle. All right, so here's some contact information. Courtney@mirantis.com. The email will come to me and a couple others. What else? We are on the CNCF Slack, and there's our GitHub links. And I think that's it. And I think I just have call to action, start managing clusters, start building platforms. But here, thank you very much for letting me come and speak.
There are a handful of questions, but we are basically over time already. So I'm going to ask people to find Martin later. We're going to take a break now, come back at 8 o'clock, and we will have our third talk of the evening. Thank you very much. Have you got Wi-Fi?
No, not yet. I've requested for it.
Oh, Stephen's not here tonight. I need to give you a number. Luca.
Oh, I mean, it is.
So it's Luca.Robinetti. So ROBI. Wait, but this is supposed to be your email address.
Sorry? Oh,
this should be your one.
Oh, okay.
And then Luca on the next one.
There's things like
We've actually met in Seychelles. I used to work at so last year at
Oh, that's nice. Wow. So small world. Yeah. I'm really bad at removing.
No, no,
people,
no.
So these conflicts. So
Yes.
but yeah.
So, yeah, I need to on that a while ago.
How do you get?
Yeah, it's good, good. Yeah. Going pretty well. Lots of interest in it now, especially with the AI stuff. Yeah, like OpenAI working.
Okay. Is it remote?
We are growing those. I think lots of the AI companies like OpenAI and stuff. Authorization, like the drag. So don't want to jinx it, but it's going pretty well. Okay, I've done this.
Let me just find Luca.
Okay.
I think he's sitting outside.
Okay.
In the test and stuff, yes. You may want to show this. Yes. It was selected. Okay. Okay, so it's actually back.
It's a lot. I bet. Oh, I haven't had other tests. I want us to put some
No. So, what it does is it understands. Really test to section service. It's testing its solution. Yeah, makes sense. So that's all generated as a file.
Yeah, I'm in.
Yes.
I saw that you just are.
Yeah, took the summer off to chill. Yeah. Good. I mean, I have young kids, so it's not really chill.
Yeah.
Are we starting again? We'll start at 8 because we want to clear out.
Okay.
Join the Zoom, yes. You have the Zoom in.
I think I do.
Zoom link, yeah.
Yeah, essentially.
Yeah, because the live streaming and the recording goes through Zoom.
Got it.
So that's what generates.
So I also need you to use the microphone so that
Yeah,
we get
yeah.
audio.
So, does the audio go through, like, do I have to have my audio on as well?
No, so your audio should be on.
I'm going to share my screen.
So you should be able to just share it. Just try sharing it now.
Would have been really good when I was.
Okay, yeah. Okay. You might as well leave it up. I mean,
Yeah,
we'll
just
be
one
back
thing.
into.
Yeah, I have like a quick, like a small demo, so that's also visible. Perfect. Yeah, we do.
Yeah. So just took the summer to. First time for kids in the family, go and do a bit of travel, do some house building stuff at home, all the usual things that kind of build up when you're working.
Yeah. And
That was really fun.
Look out now, something, but I don't have very clear ideas that are kind of that I'm looking for. It's like I'm not really an engineer anymore, and the kind of roles that I do are so specialized. Like what I do is so specialized. Those kind of things don't come up to the time. So we'll see how it goes. But not in a rush.
we are hiring but I don't know what. We are hiring.
No.
Depends on kind of more.
It's like a bunch of things, like PMM, pivots, like Revolts, like
Sort of like now I do more engineering. I'm more on the business side now than I am like on the engineering side. So
Especially
I don't know.
Okay, yeah.
That's what I'm looking for. I mean, if you think it's a good company,
Exactly. I mean, like, I think the great thing having worked at a startup or a startup that like It's not one of those places that's high on the list. Who maybe not. So we are like doing like work. Everyone understands that it is like work and we just basically do it well. So life exists outside, and that's definitely one stuff. So I really like that.
Yeah, I went to startups to Korea. I really enjoyed it, but it does kind of bleed into everything else. Yeah, startups are fun. I do like startups. Yeah. Okay, let's give 5 more minutes. I'm gonna go get some water.
Yeah. Oh, it's interesting to me.
Also, yeah. So they get some kind of conferences.
Yeah, I'm curious about that.
Well-being every day. You have some good ideas.
I think so. I mean, especially when I was. Yes. You can, absolutely. So there's two ways. One is that you can completely cluster to manage stage, all control settings, which are into and then where it's interesting. So now they have.
I've seen the movie Dune.
Yes.
It's the mouse from Dune.
Oh,
It's a
that's quite
mascot of
cute.
an open source product.
Oh, nice. Oh, thank you.
Yeah, no problem. Feel free to take it. It's
Very cute. Thank you very much. Are you heading out or are you going to stay?
No, I'm gonna say, be rude.
Yeah. Stay for the pub? It does get a bit late. Get to the end of these. You got a long way to go?
Teddington. It's not that, it's not bad.
Okay.
It's a train. It's London.
just.
Just, yeah.
I was like, yeah, I know Teddington's like, is it like south?
Across the Thames from Richmond.
Yeah.
It's where I grew up.
Okay. Yeah.
So,
You lost the accent.
yeah, yeah.
You made some interesting comments about GPUs.
Yeah.
So we use it.
All right, come on in. We're going to kick off in just a minute. I need audio off. So you don't get the echo. All right. Okay, I don't see any more people. All right, please welcome to the stage Sohan, our third speaker. Round of applause, please.
Thank you very much. Check 1, 2. Hope you can hear me. And all right. Quick introduction. My name is Sohan. I live in Amsterdam. I flew in here today for this event. Thanks for having me. And yeah, I've been in the industry for 16 years now. So I've seen a lot of changes and done a bunch of big companies like Amazon, AWS, and all of that, and now work in a startup called AuthZed. I'm here to talk to you about how Google built a consistent global authorization system with Zanzibar. I'll start with a quiz question, but I'm warning you, if you know the answer to this, you might reveal your age. You're definitely not Gen Z, right? Does anyone remember this website from back in the day? Yeah? Does anyone want to shout the answer out? Anyone? Yeah. Yes, yes. So for the Gen Z people in the audience, like me, this was Google Plus or Google Circles, as it was colloquially called. And it was Google's attempt at creating a social network. Now, their idea was, unlike Facebook and MySpace and Orkut, back in the day, you could actually, instead of everything being public, you could add people into certain circles. So you could have like a family circle, and you could have a university friend circle, and only share certain things with certain circles. Now, as a social media, well, none of us use this anymore, wasn't super successful, but the internal story goes that they re-architected their authorization for this. And because of that, even now, if you have ever sent a link of any Google Doc in your Gmail, you might see a pop-up like this, right? Where you're like, hey, does the person you're sending this to, are they authorized to view this document? And if you think about it, this is actually kind of magic because Gmail and Google Docs are two completely separate apps. And there is a centralized authorization check happening in between the two. And this is a remnant of that internal authorization system. So what I'm going to talk to you today is about how this actually works in the backend and how you could also add this type of authorization systems into your internal or even external apps. Now, quick history or a quick primer on the world of authorization. In our industry, people conflate the words auth with both authentication and authorization, and they are two completely different things. So Authentication is identity, who you are. So if you've used LDAP or Okta to sign in, that is authentication. Authorization is what comes after that. Permissions. What can you access once we know who you are? And in the past, we have seen things like access control lists. Now, this is not the best way to do it, but this was how it started, where you'd have a list, say document 1, these are all the people who can read this document 1. And here's another list of all the people who can write to document 1. And then you had a list for everything. Not super scalable. Most of us are familiar with role-based access control or RBAC. I'm sure internally at your company you have this. So if you're a software engineer, you can check in code. You're tagged to a role named software engineer. If you're a DevOps engineer, you can do something on the Kubernetes cluster. Again, not the most scalable, because what if someone in the DevOps team wants to check in code? You have to create a new role, and at large enterprises, at complex scale, this can get a bit hairy. So things changed a bit, and people use attribute-based access control, where everything is broken down into an attribute. So the place you're logging in from, your email ID, your IP address, all of it is an attribute. And at the point of decision, all these attributes are checked and you get a yay or nay, right? Attribute-based access control. Now, basically, this also isn't the most scalable system at the scale of Google. So Google rethought how to do this, and they actually came up, or they popularized this idea of something called relationship-based access control. And we know this because in 2019, they published a white paper called Google Zanzibar. Now, both the white paper and the authorization system is confusingly titled Zanzibar, so bear with me. And in that, they detail exactly how their authorization system works. And in it, they mention that they could do 10 million client queries per second. And this was way back in 2019, so I'm sure that number has increased. If you're interested in things like distributed systems and in general geeky computer stuff, do check out the white paper. It's written in very readable English and not very academic. And it's about 14 pages long, super interesting read. And in it, they popularized relationship-based access control, which I will talk about. The idea basically is, instead of having lists of attributes or roles, you essentially draw relationships between different things in your system. So for instance, you have a document, steal the moon, and you have a folder, and you have a person, right? So there is a relationship between the document and the folder, in the sense that it exists in that folder. And you have a relationship between the user and that folder. And by the property of transition or transitive property, there is a relationship between the person and the document. So what can you draw relationships with? In the Zanzibar paper, they say something has to be a user ID. So if you have a Google account, you have something called a Gaia ID. You can check that out. And any object. It could be a folder, a document, a photo, a YouTube video, whatever, right? The idea is to draw a relationship between a user and an object. What do those relationships look like? Well, they could be anything. It could be a member of a group, an editor of a document, an uploader of a video. And say tomorrow Google comes up with a new product, it could be, it could be something of something else, right? But again, you can draw a relationship between a user and an object. So you have a user, you have an object, and you have a relationship between them. How do you tell the system or the computer that this exists? So the Zanzibar paper essentially describes this thing called a relation tuple, which is how you describe this relationship. To read this, start with the hashtag and what's on the right. Again, a bit confusing, but if you have a problem with it, contact Google. So you would start on the right and say, user number 3 is an owner of document 123. So at any point of time, if you've created a document on Google Docs, something like this is probably written on the back end, where it'll say user Sohan is a writer of document 123. This method of expressing relationships is very flexible, because you can also have objects relating to other objects, or objects relating to other objects' relations. For instance, you can say the group security is a member of group engineering. Now think of a time a reorg has happened at your work and what the IT and the admin teams have to do in the back end to change like mailing groups and permissions. It's a lot of work. But in a system like this, it's about writing a new relation. You would write something like, oh, group security is now a member of group DevOps, and everything else would flow into the system. So we have all of this stuff, but what are we doing with all of this? Well, the Zanzibar paper basically says that with all this data, they create directed acyclic graphs, where each user, object, and relation is a node on the graph. For those of you all who studied like computer science theory, you know that it's easy to sort of parse graphs. It's very efficient. So in the example of something like a Google Docs, say you have some document and you have 3 users. You have a reader who's Fred and Kim, and you have a writer who's Jill. You'll notice a little dotted arrow between reader and writer, which indicates that anyone who can write a document can also read the document, like you would on Google Docs. And again, the idea behind this is flexibility. You want to support all of Google's internal products at any point of time if they change. So for instance, suddenly Google Docs decides, hey, you know what? We need to add an organization field to our permission system. So in that way, super easy. It's just a new node in the graph. So you can add an organization, call it Acme, and say any admin of that organization is a writer of the doc. And we know that all writers are readers of the doc. So this essentially gives a company the size of Google both scale and flexibility to model their different products and any changes that might happen to it. So what happens when you want to check for a permission, right? So say you've opened a Google Doc and the system wants to know whether you can access it or not. The idea basically is if, say, the check is for Jill can read some document, if there is a unidirectional way to go from some document to Jill via the permission that's asked for, right? So if there is a unidirectional way to traverse this graph, that means the permission exists. In this case, there is. You can go from some document to reader to writer to Jill, and hence Jill has permissions to write or read this document. Let's look at Fred and check if Fred has writer permissions for this document. There is no unidirectional way to go from some document to Fred, which means Fred does not have permissions to write to this document. So again, anytime you see a you are not authorized to access this on Google Docs, this is probably what's happening behind the scene. Now, the question I get asked is, okay, all of this is well and good, but surely this doesn't scale to the level of Google. We're talking about like billions of users, millions of checks per second. Like, how does this work? I feel that is an entire talk in itself. So Sharon, maybe next time I can do a talk only on that. But the idea is 2 things. One is aggressively breaking down every authorization check into sub-problems, and then trying to cache and reuse from the cache as much as possible. So let me show you how that would work. Going back to our classic example, we are going to check if Jill has reader permissions on this document. But if you look at it, this actually is a union of 3 different authorization checks. The first one is this. You're checking if Jill is a reader, a direct reader of some document, and the answer is nope, that's not it. Then we're checking if Jill is a writer of this document, and the answer is yes. And the third check actually could be, is Jill an admin of the org? The 2 of them we know are no, and we know the answer is yes. So what happens in the system is the first check happens, and the answer is no. But this result is then stored in the cache. So say the next time someone asks about Kim, we actually know the answer already, because this check has been computed already. And in the system, typically, once you get an answer, the rest of the checks do not happen, right? It closes off saying, we've got an answer. We don't want to know the rest. But keep this in mind, because I'm going to have a callback to it later. So this essentially is how it works. Second question I get asked is, look, what's the point in an authorization system if you're reusing from the cache? What if some permission changes? And the paper describes this as the new enemy problem. So let's break it down. So you can read it. T1 is timestamp 1. Kara is removing Lex's permissions from secret plans. All right. T2, and this is important, the document changes, right? There is some change to the document, and Lex shouldn't be able to access it. But at T3, Lex attempts to read this and is able to get it because of the cache, and chaos ensues, right? Because Lex is not supposed to read these documents, and many past examples of authorization systems fail this new enemy problem because you want consistency at a global level for something like this. So how does Zanzibar solve this? They actually do this very interestingly with something they call a Zuki, which presumably stands for Zanzibar cookie. They don't mention it. It's my wild guess. But essentially, every change is represented by a Zuki, which is a token which represents a specific point in time. So suppose someone creates a new folder or a document, a Zuki is issued. Say someone makes a permission check or a permission change, a Zuki is issued. So at any point of time, you can embed a Zuki while making a permission check and saying, this is the point of time at which I want to check my permissions or anything after that. So that way, you can actually avoid the new enemy problem because you can send a Zuki at time T2, and then it'll be like, hold on, at time T1, which is before T2, Lex is removed. So, don't read from the cache, get me, the latest permission. And so Lex will not be able to read the secret plan. Yeah, so this Zuki is a way that Google actually solved this issue of a stale permission check. So this paper came out in 2019, which actually is not very long ago. And it sort of set the IAM, the Identity Access Management world, on fire because everyone's like, hold on, this is pretty cool. Everyone, is doing it differently. In fact, companies like Carta and Airbnb, they re-architected their entire internal authorization system to actually mimic this, and they still use these systems. And at the same time, people started writing open source versions of the white paper. Now, this is a very common lineage of a Google product being open sourced outside. The most famous example being, anyone? Of course, Kubernetes. For those of y'all who may not be familiar, Kubernetes was an internal Google product. It was called Borg, and they used it for cluster management within Google. And then they open sourced it, and the community sort of de-Googlified it so that the rest of the world could use it. And now we all use Kubernetes. So in around 2020, that's when we started seeing all of these open source versions of the Zanzibar paper, which I'll talk about. I'm going to touch upon an interesting bit in the paper, which is how Zanzibar handles what they call hotspots. And I'm quoting from the paper. They say, we found the handling of hotspots to be the most critical frontier in our pursuit of low latency and high availability. Again, very complex topic in itself. I'll give you a bit of the TLDR. So basically, they have multiple versions of Zanzibar running on different nodes, and they have distributed caching, which can, which sort of is self-aware about where index checks are stored. So when a request comes in, it knows that this particular permission check is stored or cached here, and it can reroute it through this distributed hashing. It also uses something called a lock table, which avoids a cache stampede problem. So say 50 people try and access a document at once. It actually makes 49 of them wait and does the permission for one and gives everyone else the cached version, right? So this is using something called a lock table. Lots more there, but what happens when it's a really hotspot? Say a video has gone viral or someone shared a document to an entire organization of 100,000 people. So something interesting actually happens where, remember when I said something like this, where the subchecks are canceled? When it's a hotspot, Google Zanzibar will actually go through the entire check. So it will not stop once it's found a permission check. It will go through the entire thing and then store everything in the cache so that all of these people who are accessing it can get the cached version. So that's how it solves this hotspot. And interestingly enough, from the paper, and this is literally just a screenshot, because of how it's architected, they can actually save 500,000 internal checks per second because of how it's architected in terms of cache and so on, right? Which I think is a very impressive number. So if you're looking to build for scale and low latency and high availability, look at a Zanzibar-like system. And Zanzibar does shine in few use cases where you need low latency, where there are relationships between lots of objects and documents, financial data. And we're also seeing it being used now in things like RAG pipelines in AI. In fact, OpenAI uses a Zanzibar-like system for their 37 billion documents in their new product called ChatGPT connectors. So it's where you can connect ChatGPT to Google Drive or Dropbox or Box. And they actually use Zanzibar because it can handle the scale of ChatGPT. All right, so how can you actually use a version of the Google Zanzibar paper? There are, I think, 4 famous, at least, implementations of Zanzibar. There's SpiceDB, there's Ori, there's OpenFGA, right, the one here, and there's Permify. All of them are completely open source, and they're based on the Zanzibar paper. I'll speak a little bit about SpiceDB because at AuthZed, we help maintain the project. SpiceDB is completely open source with contributions from people from Google, GitHub, Netflix, Reddit, and so on. And the metric that matters most to us as developers and SRE engineers, of course, is GitHub stars. So we're close to 6,000 GitHub stars, could always use an extra one. So if you feel like, please go ahead. But again, SpiceDB is an implementation of the Zanzibar project. And what it is to us as platform engineers or developers is it's pretty much an API, right? So it's written in Go, and it's a highly parallel graph database that's optimized just for authorization queries. Despite the name, SpiceDB is not a general purpose database, so you can't use it as an RDBMS. It's purely meant for authorization queries. In fact, you will always use it with a data store like Cockroach. We have someone from Cockroach here, yeah, or Postgres or any other database. So it's not actually storing things in itself. And what it's optimized for is authorization queries. So I can show you a quick demo of how this would work. And again, all Zanzibar systems work pretty much in the same way. There are 3 components to it, and the first one is called a schema. Now, again, this is described in the Zanzibar paper, where a schema models the use case that you have. Again, Google wanted flexibility for docs and mail and maps and so on. So how do you model that as opposed to putting everyone into a role or an attribute? Well, you do so with the schema where you define the users, the objects, and the relations in between them. So in this, I define a user, I define an object, in this case, it's a document, and I define the relation between them. For instance, a user can be a writer or a reader. If you want to add, something like a commenter, for instance, I can just say commenter is user, which is a new relation between user and document. I'll just comment that out. And for every relation, you can add permissions. So for instance, a writer can edit the document, but both a writer and a reader can view the document. So this is how you would describe a schema. And let me try this. Yeah. And the idea behind a schema is you can model pretty much anything you want. So for instance, you can do IAM roles. So fun fact, and this is absolutely true. Oh, you can't see my screen. Something like this. Yeah. So Google's IAM in their cloud product is based on the Zanzibar paper. It's a fork of the Zanzibar internal authorization system. And this is what it would look like. You would have a user, you would have a role, And you'd have different roles, like someone who can cancel a database, someone who can get the list of databases. And for each of them, you will have permissions. So that's essentially how it would work. But for now, we're going to stick to an easy example, which is a Google Docs style thing. So that was essentially a schema. Once you have a schema, you need to create relationships between the users and objects. And again, with SpiceDB or Zanzibar, you can create, read, update, or delete relationships. So if you want to add relationships such as this, you would add them in the form of a relationship tuple, which I mentioned here. So I can say something like document second doc. We can add a new reader. And I will say user is me. So in your app, typically, you would write this in code. So every time a new document's created, an API call is made to add a new relation. Yes, no, go ahead. Yeah. Yeah, so the question was, if I have 1 million users, what do I do? So all of this is done programmatically. So every time a new user is created, you're also creating a relation between the document and the user. So it's not done in one shot. So say a user creates a document, you would create an API call to actually do something like this. Right.
So how do I add all those users in the schema?
So when a document's created, a user creates that document. Like say you create a document, right? So right. Yeah. So we'll take Google Docs as an example again, right? So you create a document. So internally, when your name is Ram. So when Ram creates a document, programmatically, you will make a call to add this relationships, right? So then say, Ram, you share this document with me using the share button, and you've shared it with me, but I can only view the document. So then another programmatic API call is made here. Now, suppose, I'll get to that. Suppose all of us are in an org called Cloud Native London, and say you share that with Cloud Native London, right? So then that relationship is also written. And as the permission, we all have access to that document. So that's how it would work. Mm-hmm.
Even if it's programmatically written.
Right.
Let's say I have about 100,000 users in our organization.
Mm-hmm.
They will be having varied permissions to see, read, view varied set of documents.
Yeah.
Or a component of an application, right?
Right.
So all of that goes from our back into this one, right?
Yeah. Yeah.
So how do you discriminate and then how do you programmatically capture as to who has got permission?
Got it. Okay. So your question is, you have an existing system with a bunch of permissions and okay. Right. Mm-hmm. Right. Right. But you have all this data already. Yeah. Like someone knows it, it's listed somewhere. Right. Yeah.
Creating a combination of 100 users into 100,000, which is split into various groups, kind of a line of codes for permissions.
So it's a fair question, but you would also be doing it on how your system is modeled, right? So say, yes.
You have huge number of roles, right?
Yes. Yeah.
That's what I'm just saying.
Again, it will completely depend on your system. The reback actually can also model RBAC. It's like a superset. So if you want to do that and say you have just 3 roles in your system and you want to model that, you can do that. If you have very complex requirements, like in most modern organizations where some people have some access and whatever, then that has to be modeled in your schema and run once and everything will run. So, and the cool thing with schema is you can have nested permissions, you can have document folder, you can have admin permissions, you can have intersection, you can have exclusions. It's very flexible in what you can do. So if you have all of that ready, it's just a matter of modeling your schema and running it once. Yeah, pretty much. You have to run code basically for that. Yeah, that's a fact. No, that's a very fair question. Yeah, so essentially, this is how you would write relationships. Here, of course, I'm showing it to you in like a CLI type tool, but you would do this in code typically. And finally, you will check for permissions. And this is how permission checks usually look like. One is you check for permission, which is simple, right? Does Niv have writer access? But you can also do lookups. So you can look up all the subjects that can read some document, right? So for instance, in this case, it would traverse all of these people as they all have read permissions on the document. You can also do a reverse lookup and say, give me all the documents Fred has reader access to. And in a real world, this is a massive graph. So you'll get some document one, all of those things. And again, I can quickly show you an example in the playground right here. So this is just, again, a CLI tool, but you would be doing this in code where I say that permission check, say document, first doc, view, user, Tom, right? And it's true because we know that Tom is a writer, so Tom can also view the document. But if I change that to maybe my name, who has access to just second doc, it says false. And you can see how the check actually happens. It looks at document first doc, it says not a reader, not a writer, and those are the sub-problems that I was talking about. So essentially, that's how you would do a permission check. Now, why am I giving you all of this information? As Ram mentioned, for the many past years, like RBAC has worked very well. We all use it. I think the idea is our organizations, our requirements, our customer requirements have gotten super complex, and people are struggling with things like just role-based access control, and they're looking for something else. Or a very real use case is you have 3 different apps which have 3 different authentication methods. How do you reconcile all of that to the same permissions in your app? And most importantly, anyone here heard of OWASP, Open Worldwide Application? Yeah, everyone, of course. If you've checked in code, you've heard of OWASP. So it's an industry body. They make lists about security, web app risks, and so on. And in their most recent list, the number 1 in the most critical security risk to web apps is broken access control, because this has gotten a very complex problem to solve right now at scale with millions of users. And Zanzibar-like systems help in many use cases. Of course, it really depends on what your use case is. So yeah, if you're interested, do read the paper. I think it's a very interesting read in general. And also check out SpiceDB or really any other Zanzibar system if you have authorization needs. And hope you learned something new today. Feel free to connect with me on LinkedIn, or I'm here around as well. Thank you.
On time. We are out of time for this evening, so I'm afraid any questions, please ask Sohan in the pub afterwards. I want to say thank you to everyone for coming and joining us at Cloud Native London tonight. When you go out, please remember to leave these key fobs here. And then if you're going to the pub, we're going to the Conductor, which is just out the front door, straight in front of you on the left. We'll be back on again on the first Wednesday of next month, October. Thank you very much. Have a good evening.